Good morning, thank you. In this talk, I'd like to share with you a lot of the experience that we've had helping companies go towards a model of continuous delivery. And a lot of it will be about the lessons and the challenges that companies face. And hopefully you guys will be able to take some tips back with you into your own sort of companies. I work for a company called ThoughtWorks. It's a global consultancy. Martin Fowler is our chief scientist, and Jim Highsmith is also another one of our executive consultants. We have 3 products: Mingle, Twist, and Go, which happens to help with continuous delivery. I also happen to be quite passionate about retrospectives, and I have a book. So if you'd like to talk to me about that in the breaks, I'll be around. But onto the topic of continuous delivery. How many of you are sort of familiar with the concept? Okay, quite a lot. So we'll probably be able to go through this pretty quickly. What's really interesting is that there's a lot of confusion about what continuous delivery is. People talk about continuous integration, continuous deployment, and all of these things kind of blur together. And for us, what we kind of try to define about continuous delivery is the capability for companies to release software to production on demand. And this is about business demand. It's not really about when a developer decides to let stuff into production. Businesses get really afraid about that. And the other key difference about effective continuous delivery is this idea of confidence. So when we talk to companies about releasing software fast into production, everyone goes, oh yeah, of course I can do that. Log onto the server, I can hack something together and push stuff out. That doesn't really get you very far very quickly. And so a lot of the practices behind continuous delivery are about building confidence and speed into your delivery pipeline of software. Now, hopefully, most of you are familiar with Agile, and what's really interesting is a lot of the practices kind of deal with the sort of insides of the team, the sort of requirements with the customer, trying to deal with the sort of software groups and integrating a lot of the technical practices. We're big fans of XP and sort of TDD, trying to make sure that you're kind of building stuff right. And a lot of that sort of stuff is kind of dealing with the sort of building of software. And where I think continuous delivery fits in is really about that last mile. So when you've sort of built stuff, how do you get that into production and work with other groups that suddenly you've had challenges with environments and operations? And it's really interesting because if we go back to the Agile Manifesto, one of the principles that they talk about is this idea of satisfying the customer through the early and continuous delivery of software. So it's not really a new concept in terms of the Agile space, but a lot of the sort of methodologies, a lot of the talks that people talk about don't address it. Who's familiar with the Poppenticks? They're sort of people that talk around sort of lean software development. And one of the challenges they have with sort of companies is that they ask, how long in your organization would it take to deploy a single line of code into production? And can you do that on a repeatable, reliable basis? And actually, that's a really good litmus test for how effective your continuous delivery pipeline is. So they have this idea of a lead time of requests queuing and trying to understand from when a customer asks for something, how long does it take to go through your software delivery process? Not to the point where suddenly your development team can showcase to people, here's what we've built, but actually to the point where customers are using that feature. And that's the key difference. It's about getting stuff into the hands of the people who asked for it and starting to get that real feedback. So it's about this idea of constant flow of features into production. There's a couple of key things here, is that trying to keep your software production ready is a key characteristic. And really trying to tie releases to business needs. So often when we work with companies, they're doing sort of Scrum or XP, they're building software. But they're still sort of tied to this, we only release once a month because that's kind of the release slot that the operations people are giving us, where we can support that into production. And that is still a technology constraint on the business. And this is where a lot of the CD practices are trying to address that. So it's not just about an IT-driven initiative, but it's that capability for a business to release on demand with the support of technology. So continuous delivery is not about continuous integration. It's also not about continuous deployment. And what's really interesting is we talk to people about continuous delivery a lot, and they also think, well, continuous delivery means about the tooling. So, if I'm using Puppet and Jenkins, then I'm doing continuous delivery. Doesn't necessarily mean it's the same. And there's a lot of benefits to the business about selling continuous delivery. So obviously one thing is if you can ship stuff out faster, it enables the business to experiment with some of the things that they can do a lot more. They can validate ideas, sort of the lean startup, trying to test things before you build out massive amounts of software on it. Costs also become a little bit more predictable. So instead of big batches of budgets where you don't really know what things are actually earning you money, you can actually test things and start to amplify the effects of that. And the bigger thing, which is even more important in today's sort of ever-changing industry, is that you can respond to customer demand. So what's funny is that a lot of companies who are adopting Agile, they see it as a way of delivering software faster, but they're still thinking in terms of sort of 3 or 6 month batches of software. And by the time that they build and deliver that to people, half the features are probably not going to be used. So continuous delivery gives people the capability of doing things smaller and testing and amplifying that. From a technology perspective, there's also benefits, because each sort of small change that we add to our code base adds risk to the overall release. So actually, when we release it into production, we can actually learn a lot more about our infrastructure, and we can actually get feedback about how effective our development process really is. So before we delve into sort of the what you do in continuous delivery, I think it's important to think about what are the things you should focus on as a delivery group, so the principles and the ideas behind a lot of this. So we'll explore some of those things. One of the key things is about automating and really trying to think about how you automate stuff. So that's the repeatable, reliable basis. The other great thing about automation is that you're not really relying on sort of humans to sort of make everything effective. Now, humans are important because we can do a lot of value-added stuff, but when it comes to a lot of the repetitive tasks, we make a lot of mistakes. Computers are much better at that sort of stuff. The idea of build, deploy, test, and release, and really building a cycle around that sort of stuff. And a lot of the sort of delivery practices that we work with in organizations, they focus on effective build and effective test. So, how well does our CI server produce an artifact, and have we tested that? And they often forget about the deployability and the releasability of software. And all of these things kind of affect each other. In fact, one of the biggest things that we've found with customers is that when they're architecting or deciding about buying solutions, they forget about the configurability and deployability of that software. And that becomes a major hindrance to their ability to release fast on demand. If any of you have had to work with, say, an enterprise service bus or some sort of central messaging system, a lot of that stuff can be very difficult to configure and to deploy effectively in a lot of places. The ideas of proprietary licenses, of expensive licenses per instance, often becomes a barrier to being able to reproduce new environments and get fast feedback around changes in what you do. So a lot of these principles affect much more than simply the deployment process. It affects our architecture and our design. We need to be thinking about a lot of that stuff from the beginning. The other thing about continuous delivery, a lot of people say is, everything's going to be automated, and we don't want software suddenly released to our users without understanding that. And actually, there is a place for manual testing and approvals. Continuous delivery isn't about removing humans from the process. The businesses, like particularly traditional businesses, that they hate the idea of a developer checking stuff in and a feature suddenly appearing. It may not align with what they want. They may want a whole set before they sort of release it to end users. And so there is a place for allowing for approvals around that sort of stuff. I think automation of everything is also sort of pretty much impossible. So when you're talking about exploratory testing, so things that you can't predict, it's very difficult to automate that stuff because you don't know what you're really doing. Usability sort of testing and sort of the interactions of UIs, that is also something that's very difficult to automate, although people are starting to try to look at that problem. So we can do a lot of automation, but there is still a place for some level of manual testing and maybe some level of approvals. One of the biggest pushbacks you get from operations are, we don't want stuff going to production because it needs to be controlled. Understandably, they'd like to know what's going out into production as well. And so there's probably some process for allowing for some sort of manual review, which is normal gating. And all of this is very good, it all works very well with CD as well. So humans, it's really important to use them for the high value stuff. And that's a really key thing, is that automation doesn't get rid of humans. It changes the nature of the work that we do, and that we can actually focus really more interesting things. We can start to look at more challenging problems rather than repeating the same tasks over and over. Another sort of principle that we like to say is putting everything into source control. And this is where actually product selection makes a big change. So we talk about putting environment configurations into source control. We talk about putting tests into source control. A lot of this comes down to sort of control and repeatability and being able to do that. There's another sort of principle that we talk about, which is if it hurts, do it more often. The natural reaction is, oh, it's painful. Oh, we don't want to do that very often. And actually, the pain is telling us something about our process. And if we can actually learn from that pain, the idea is if we can bring that forward, hopefully it'll become less pain overall. It's like having a healthy habit of exercise, where you're sort of dealing with things before they become significant problems later down the line, and you can actually do things to do preventative healthcare rather than simply diagnosing and giving people drugs or something like that. So if it hurts, do it more often and bring the pain forward. Now obviously, don't just simply put up with the pain. You want to actually do something about it as well. The next principle is about building quality in. So I think most software houses tend to inspect quality in. So they're constantly testing, they're constantly prodding. But actually, a lot of the things upstream in software development process are the things that affect quality. Testing is often one of those things that kind of demonstrates the level of quality, but it's not where quality comes from. It shows you the level of quality that's there, but actually we have a lot more to be able to do. So, the things like TDD helping to bring testing forward helps to improve some level of quality. And actually, there's a lot of things that we can do to improve it much earlier on. So, if you're familiar with Lean, Edwards Deming is kind of like a very classic person. And this quote is quite a really nice one about talking about quality. I'll just give you a second to read it. And Demings is sort of the person that kind of thought about lean thinking, and this is the sort of approach that Toyota takes. There's another thing about done in sort of continuous delivery. So how many of you are working in sort of agile teams? Okay, quite a lot of you. Now, how many of you measure done is in the hands of end users? Okay, not so many hands. And I think this is the thing. It's very easy to measure the things that are within our grasp. And often as developers, and I know this because I work with a lot of customers and operations are a different department, it's easy to measure the things in your own sort of space and say done is when we're kind of done with the stuff. But actually when it's over with another group, that's harder. We don't have any control over that. But actually what's really important is that we extend what done means into release. Because it's only then that we'll understand, actually, maybe we're optimizing for our small part of the process. And if we actually focus on the overall flow into production, there may be bigger gains if we help the next group of people as well. So done means done when it's released to end users. And actually, a lot of people talk about done not being done until you've learnt from the things that you're seeing in production as well. But then it gets a little bit crazy. There's another thing about responsibility. And I think Agile's done a lot to break down silos, but we have a little bit more to go. We need to bring in the people from operations. And in that spirit of done, and bringing everyone in, we need to really bring in that spirit of continuous improvement. And often this means breaking down sort of responsibilities and incentives to help people improve their own processes. Okay, a lot of principles, but these are the sort of background ideas and gives you an understanding about why we do some of these practices, which we're about to explore. So a lot of these practices are the things that I see very frequently in a lot of implementations of CD. What I highly recommend before we sort of delve into a lot of this stuff is you don't do all of them at once. What I'm presenting is really lots of different strategies that we see that are effective for lots of companies. But each company often sort of alters it depending on what they have. So they definitely contextualize a lot of that stuff. So one of them is about that comprehensive configuration management, putting everything under test. And also excellent automated testing at all levels. So it's not just about automated acceptance testing. So it's interesting when you talk to people about BDD frameworks and automated testing, because it tends to encourage a lot of automated acceptance testing. But actually, it's really important that we have a very good level of unit testing as well, because that's the source of our sort of automated feedback. And automated testing doesn't just mean about the sort of features of the software, but actually we should also be looking at automation of some of the non-functional things. So we've worked with customers to put sort of performance testing into their delivery pipeline, where it's a key characteristic of the application, because they want to find out early ideas of when things are regressing. Where security is important, there's a lot of automated tools that can do analysis, particularly static code analysis of vulnerabilities. And those things that are levels of automated tests you can bring into your pipeline as well. So it's about trying to work out what you do. There's also the idea of continuous integration. How many of you are running sort of continuous integration on in your projects? So quite a lot. That's great to hear. So I think CI, so this is a kind of diagram flow of what a CI thing might look like. So the top level boxes up there are kind of stages within a continuous integration build. And then there's a series of workflows that kind of happen. So a developer checks in, and then it triggers a couple of builds. And what you're trying to do is optimize for fast feedback early in your pipeline. And then if that goes red, you want to actually add a new fix to the code. So they check in again, and that triggers another build. And once that passes, we sort of move on to the next stage. And so the idea of pipelined builds and feedback is kind of that key concept in continuous delivery. And we can extend that metaphor to more than just the development side. So in this case, we move on from automated acceptance tests to user acceptance tests. We can extend the pipeline even further if we're starting to think about perhaps exploratory testing. So we have different types of things, like where we might do some deployment tests. So we're testing early to see whether or not our software will work in a production-like environment. And maybe this phase of UAT isn't actually a automated one, but it's actually a set where end users are exploring the software, and once they're kind of happy with it, they're sort of marking that as approval. So a key concept in sort of continuous delivery is thinking about how you visualize the pipeline of work into production. Not everything has to be automated, but you get a sense of what things are potential candidates for builds. So hopefully all these sort of green boxes at the end are the things that are potential candidates to go out to production. And then, when the business would like it to go out, the last stage is simply approving it. And so the idea is that you have a combination of automated sort of feedback processes, and it's okay to have some manual approval stages, depending on your organization and how much sort of control they would like of different things. Of course, you can be like Facebook or Etsy and maybe have automation all the way into production, but that is a business choice. So it's a strategy that different companies have. So if we look at the ideas of a pipeline, really what we're trying to do is bring production constraints back earlier into our process and get earlier feedback around that. So the essence of the continuous delivery pipeline is bringing faster feedback earlier into the process. At the same time, as builds progress to the end of the pipeline, hopefully we have increased confidence that this thing will go live. So we're starting to get into the idea of repeatable and reliable. So the things that don't make it all the way to the end, they're the things that are definite candidates not to go out. And of course, you can have parallelization here, where performance testing will be automated, and then at the same time you have your user acceptance testing. At the same time, one of the key things is reproducing production environments can be very expensive. So there's a trade-off around a lot of this stuff, right? So setting up a production environment, depending on the complexity of your application, could be very hard for a developer machine. So if you have multi-cluster, multi-node, if you depend on physical hardware, that can be very difficult. But one of the principles that we talked about bringing fast feedback earlier is seeing if you can create constraints that bring it back earlier. The wonderful thing about sort of cloud-based type stuff is that there's a lot of tools like Vagrant that allow us to simulate multi-server things locally on our developer machines. And often the constraint is really about sort of processing hardware and how much access to resources you have. So there's a lot of things that we can do these days to actually bring that stuff back earlier. The idea of trying to deploy things locally in the similar way that you would deploy to a later test environment and in production, in my experience, is often quite different in the development sense. So think about ways that you can deploy locally that's the same way, and you're testing that mechanism as well. So faster feedback. Normal patterns that we see are things like a commit stage, so it's the fast feedback the unit tests. It runs against every check-in. And the idea is that it creates a release candidate. So if it fails, the idea is to fix it immediately. So the idea of stopping the line and instead of building problems on top of an existing problem. Acceptance stage is another sort of phase. So the idea is you've created a candidate and you're progressing it to the next stage and you're polishing it up a bit more. There's a temptation that I often see in different environments where people will rebuild another candidate for a later stage. And it's kind of an anti-pattern that we discourage, because every time you build a new sort of deliverable, there's a chance that one more change might slip in, and so you're not testing the same sort of artifact. In this phase, we typically see a little bit more like an end-to-end production thing. It's a little bit more maybe against a real database. And it's triggered only after the other stage has passed. So we know that the other build is good to a degree, and we're trying to get more confidence around that. Once again, stop the line. If it fails, fix it immediately. And then later stages are okay around, and typically around manual stuff. So we try to run all the automation stuff first. And then we try to run the manual stuff later. And the reason for this is that we're really trying to optimize the use of human work. So a lot of the manual stuff is often interesting things, difficult to automate. And if they're sort of running against artifacts that already have problems, you end up wasting effort. So we're trying to maximize the value that they can add. So typical examples are maybe it's a user acceptance testing stage, or something that's just before production. So pre-live, pre-production, there's lots of different names for it. And even maybe just testing against production once it's live. The idea behind a lot of this stuff is that you want the people who are running that sort of environment or using that environment to sort of self-service. So they have a catalog of all the potential good builds that they might want to have, and then they're choosing when to have it. So it's not sort of being pushed upon them. And the idea is it's a pull system. So when they're ready to, once they've done their exploratory testing on one phase, maybe they take another build and they want to focus around a certain feature there. So these are kind of characteristics that we see a lot with sort of the manual stages. We'll move on a bit more. We talked a little bit about building binaries once. That's a really good practice, and that's pretty easy to do. And deploying the same way to every environment. So using the same deployment scripts where possible, trying to plug in configuration that's different. We highly recommend doing some smoke tests against your deployment. So not necessarily running full automation against a single environment, although we have seen that at different clients, but actually trying to do a simple test to make sure things are up. So we've definitely hit frustrations before where we've deployed something, and then people assume it's right, and then maybe a sort of QA is starting to explore it, and they're the people that kind of come back and say, hey, deployment didn't work, something's not right. So a smoke test is giving us fast feedback again about whether or not the deployment was successful. There's another thing around environments, and this is starting to become more of a problem. And Martin Fowler writes about an article called Snowflake Servers, and it's normally the effects of what we kind of call configuration drift. So this is quite typical when you have, say, operations maintaining one environment, maybe QAs owning one environment. And in order to do something, they sort of make some local changes to it. But those changes aren't really reproduced in other environments. And at some point, these environments start to diverge. And these become sources of difficult problems because suddenly you're maybe testing things in unrealistic ways that we're not actually going to have in production. So there's something about trying to keep your environment similar. And like every time, if it fails, stop the line and fix it. So there's a temptation to keep pushing more things through, but actually we should be looking at root causes and trying to address some of that stuff and build feedback into our pipeline. when we build binaries, it's really important that we version artifacts. And a lot of CI servers allow this as a really easy way. So there's two kind of mechanisms that we typically put in. So one is the source control kind of build. So maybe it's a version or git hash. I don't know if TFS has a labeling thing. I'm assuming it does. But you put that into the code. So you can quickly jump back to this binary was built based on what we thought was in source control. The other mechanism is looking at getting your build server to tag it with its own build number as well, so that you can actually identify this was built by this sort of CI server, and we can look at the environment variables that maybe were built into that configuration as well. And a lot of this just comes down to reproducibility. So what we want to be able to do is, as soon as we detect that something is wrong, we need to do a lot of things to sort of isolate what are the possible causes. And if we have a good understanding about what the possible changes are, versioning really helps kind of with that sort of stuff. So yeah, we check in and we should get a different version, and every change that goes in there should trigger another version upgrade. So it's pretty simple. The other thing is when you're dealing with very complex sort of environments with a lot of deployments, you know, when you get some weird behavior, one of the problems that you often have is a deployment failed and maybe one node in a cluster, but everything else went through. So you get one aberration of some behavior behaving slightly differently. And so if you can actually sort of do a remote sort of ping to that server and see what the version is, you can actually at least start to narrow down, actually this thing didn't deploy correctly and therefore we just need to redeploy it onto that server. So it's very helpful in sort of debugging and sort of narrowing down the amount of things you have to go through. The next pattern, which is kind of related to building an artifact, is about environment configuration. And in some places, people bake their configuration into their binary. For some application architectures, it's very difficult to not do this. So for instance, if you're trying to do iPhone applications, and you're trying to point an application at a test environment server rather than a production server, you kind of have to build a new artifact for that just because of their sort of deployment model. But ideally, what we're trying to get to is some sort of pluggable architecture. And this is where we need to be designing software to be configurable from external sources. So we produce one binary artifact, and the anti-pattern is actually building one for each kind of environment. And the ideal is that we just have one binary, and maybe through a configuration file or a configuration table, it depends, trying to plug in, here are the values for development, here are the values for sort of test. And then in production, we do something different. In thinking about architecture and product choice, we touched upon this a little bit well. A lot of these decisions often get made by different people. And when you're a developer, you often suffer a lot of these sorts of consequences. And we get a lot of questions about companies about how do we do continuous delivery when we have this big package that everyone has to sort of depend on that you configure through UI. Actually, it's really hard, because those things weren't thought about in mind. So thinking about how do you reproduce a new environment with exactly the same business rules when some sort of business user has been clicking around on a UI and it's trapped in some sort of proprietary format. It's very difficult to be able to simulate another environment. And there are products that encourage that, and there are products that discourage that. So when we're sort of talking to clients about new architecture builds, it's one of those considerations. If they want to be able to have confidence in their deployments, thinking about this stuff up front is really important. And there's a really great case study, and there's a link to the slides from Trainline. So Trainline is one of the biggest sort of ticket vendors in the UK. And at the heart of their system is a business rules engine that people have for doing their pricing of tickets. And what's really interesting is that they've been moving towards a model of continuous delivery over the last few years. And one of the key components that has been a big struggle for them has been this business pricing thing. So A, licensing makes it very difficult for them to reproduce other environments. And B, everything is through a clickety UI, and they can't put rules under source control. So reproducing other environments becomes very difficult. So, you know, they talk about a well-known monolithic business rules engine that's costly to build, deploy, configure, and test. And what they've decided is that they're going to be moving away from it. And I think they've pretty much completed their migration away from it to a simpler, sort of more in code kind of thing that adheres to a lot of these principles. Obviously, it takes a while to be able to architect a big replacement where there's a lot of dependencies, but it can be done, and there's good reasons for it. So, a good practice that we encourage are short-lived feature branches. How many of you use Git here? And how many of you use feature branches? Okay, that's kind of a mix. I don't think feature branches are necessarily a bad thing, and I think the key thing is really about how long it lasts. So a great example that we have is, when you check stuff out from your sort of central source control repository, your local development is effectively a branch. Now that's not really a problem unless you sort of keep your changes local for a month. And then as soon as you start to integrate the stuff back, you end up with merge problems, right? And then once you get over them, you may actually discover your merging caused other problems that, it's still compiled and assembled and the tests ran, but maybe there were business logic things that were missed. So one of the things is really trying to aim at keeping feature branches very short-lived. So branch if you need to, but ideally trying to merge stuff back. And a good rule of thumb is more than a day becomes a bit of an anti-pattern. So we try to encourage teams to check in at least once a day into trunk. Cool. So inside-out development is like one of those questions, right? So a lot of people kind of talk about how do you prevent a feature from appearing on a website if I'm continually checking into trunk, right? So if your pipeline is really great and you have 12 people developing different things and you're releasing daily or weekly, how do you make sure that a feature that's maybe taking a couple of weeks to develop doesn't suddenly appear on a website or some product? And inside-out development is one of those strategies. So, the idea is that if you have some sort of logical layered architecture where you have maybe some infrastructure type stuff, maybe work on the database changes first. So, and when you check that in, you get that into production, there's no change from an outside perspective. You might then start to work on, say, business logic, controllers, the interactions of stuff, but still there's no way for anyone to be able to access that sort of stuff. Then you might work on configuration, making sure that it works in different environments. And maybe the final thing is some sort of UI thing. And it kind of depends on different strategies for that. But this can be a really effective way of trying to sort of develop incrementally, release things, get confidence, and then at some point you can sort of turn that on. Another one is, well, obviously don't push until you're done. And this works very well when you're working with sort of small sort of features. But once again, it's a branch, so keep in mind that we'd like to check in very frequently. Another strategy is around parallel routes. So it's this idea of branch by abstraction. So a typical thing is, we'd like to change the behavior of some module, but it might take some while to develop. So what we might do is introduce some sort of interface in between what we want to have and some current implementation. At the same time, we'd like to work on the new implementation and start building that out as an algorithm. And then at some point, we sort of switch over. And then we might have some configuration that allows us to sort of toggle between these two implementations. And once we're happy with it, we can remove the other implementation as well. So that's kind of a nice little strategy as well. We get questions a lot about data migration. So, we talked about what happens if we work on the database layer first. And people often say, well, you can't do that because, we have one code that kind of works in one set of schema and another code that works in another set of schema. And really one of the things is thinking about how you design code that can work on both of them. So a typical one is thinking about how you maybe rename a column or something like that. And so the first step might be is that you actually add that column, but you don't remove the other column until you know that you've migrated across. Then you might have parallel writes to both sort of places to allow old applications still to kind of work and new application. Once you are sort of released into production and you know that nobody's using that old application, you can then write a drop column or something like that to have migrated stuff along. And a lot of this stuff really comes down to real good synchronization between the code that you write and your releases into production. So once again, we have to think about that strong relationship. Another idea is around feature toggles, and we often talk about 3 different groups of feature toggles. So you have kind of the dev-facing ones, And there's characteristics of it tends to be very small, around a sort of small block of code, and it's not something that you kind of have for a very long time. So as soon as you're sort of released, then you remove those toggles. You might have operation toggles, and these are typically things that are based on environments, so something, a different configuration for maybe QA. And then you typically have the business-facing ones. And one of the things that we try to encourage when we talk to people about feature toggles is understanding the differences between them. Because what often happens is that the business often hear about dev toggles and they want to have control of it. Oh, I'd like to have that. But we end up with quite a lot of these toggles because we're trying to work in small increments. And one of the things that you end up with is this idea of a feature toggle frenzy where nobody really knows the configuration anymore of what's in production because there's so many of these things. So you have to be a bit careful around a lot of that stuff. You want to sort of remove toggles and keep them short-lived and minimize the number of business sort of configurations. Another thing that kind of helps with and this is kind of more newer sort of products, is this idea of traceable deployments. So, you know, we get sort of caught up in our development cycle of trying to build out these new products, get it ready, and then suddenly we have to deal with deployments, and then we find out actually these assumptions about these environments are different. The idea behind a traceable deployment is doing the smallest application you could possibly have that's representative of your application architecture. So for instance, you might have a screen that writes to a database table or to some message queue or something like that. And the goal is for us to sort of get that through the pipeline all the way into production as early as possible. So you know, we end up with, oops, sorry. So we end up with sort of this idea of trying to get a system through from end to end. And the real goal behind that is really thinking about what are the constraints that are different across these environments because we don't know about it. So it's that fast feedback about differences. You know, we might find out that there's a firewall configuration in production that's different from our pre-production that prevents us talking. So we learn about these things pretty early. A good goal is actually around having a push button release. And this is kind of going back to that capability to do things on demand. And ideally, we want to get to some point where the business owner is doing the deploys into production. Now, you may not start off that way, but you kind of depend on automation for a lot of that stuff. The other idea behind continuous deployments is trying to understand the differences between separating deployments from releases. So our code gets out there, but maybe because of the way that we have feature toggles, we don't actually have to release features to users unless we want to. So the idea of maybe trying to test deployments, get new code out there, we understand the stability around that sort of stuff, but we don't actually have to turn that feature on for people. And if you have the capability of actually deploying really fast, a characteristic we often see is rather than rollback strategies, is this idea of rolling forward. So it's often much easier to fix something and get it through the pipeline than it is about having a rollback strategy. Because rollback strategies often mean you have to test all of that stuff as well. And it becomes quite a complex environment where, you know, your rollback, if it's unsuccessful, creates other side effects. And so reproducing those environments becomes difficult again. When it comes to deployments and we're trying to upgrade things, there's a pattern around sort of Canary releases. And this is typically what you tend to do when you have a very large scale application, kind of very cloud-based type stuff. So in this sort of environment, we have a whole bunch of things where we have lots of instances of the same application. And the idea behind a Canary release is that we decide to maybe based on users, we release a new version to a couple of different groups. And then through monitoring, we start to work out whether or not things are looking good. And if things are good, then we start to roll that out across the entire cluster as well. And so this is how companies like Netflix do some deployments. They're trying to check out to see, you know, they think it's all good, but they want to make sure it's good. And they have an ability to roll back as well to the previous version if they need to. Blue-green deployments and another kind of pattern around continuous deployments that kind of help. So this is very helpful if you need to maintain constant uptime for people. So a typical thing is that you have two environments, and you know, sometimes people call it pre-production or not, but in other places it's like two instances of your production stack. and they call it blue and green. So you have one instance that's the current release, and one instance that is your kind of upgrade environment. We deploy the next version onto the green environment, and then we maybe test to see if things are okay. We might start to route people to that environment and start to once again monitor traffic. And if we're kind of happy with that, then we start to route everyone to that environment. So now everyone is using the new version of the application, and the old application is kind of there. We can tear down that environment and then prepare it for the next release, and so forth. So it's a pretty useful deployment pattern around this sort of stuff. All right. I've talked about a lot of sort of practices around technology, and I think it's really important that continuous delivery is also about the people side. And one of the big things is this idea of organizational patterns as well. So when it comes to DevOps and that movement of bringing developers and operations closer together, one useful thing that works a lot is about this idea of regular visits. So developers go to see what production environment is like. They understand what monitoring exists. They get awareness of what physical environments are there in production. Similarly, bringing operational people into development helps them understand what things are coming up, what things might be released, and new features and things that might need new monitoring. So a lot of that stuff kind of helps. If we sort of push that a little bit further, you might even get into pairing, where developers are working on operational tasks and operations people are working on some development tasks, and you get a lot of knowledge transfer. So developers might start to understand how to do a lot of deployment scripting, and they understand how to maintain a lot of that stuff as well. When I run development teams, a really key thing that I like to encourage is this idea of developers doing production support. It's often a great way of onboarding new people because you learn a lot. The idea of dog fooding, right? So eating your own dog food, it's a really key thing. And if you have to maintain something and make sure that it works in production, as a developer, you're going to make sure you don't get that call at 2 a.m. in the morning because you understand the consequences of what you've done. When it comes to requirements analysis, we think it's very important to have an operations stakeholder. So we go into a lot of organizations who have problems with releases, and a lot of the times it's because they've sort of talked to business people about what they'd like, and the developers around what what their needs are. But they often forget about things like backup plans, monitoring, the things that operations people need in order to maintain uptime. So to balance that out, a good thing is to make sure that you bring in operations stakeholders. Bring them to your sort of showcases where you're demonstrating software and seeing a lot of that stuff. Working in small slices is definitely helpful as well. So trying to have small things. And having small stories is really useful. And there's a really good art to slicing stories to an appropriate length. We're really big fans of sort of the idea of a story map, where if you have a customer journey, so some business flow, we're trying to break things into smaller features. So we might work on sort of the first cut of stories end to end to give people early visibility around that sort of stuff, and maybe start to work on the richness of those features. So you don't have to build it all, but you're trying to get some early feedback around that stuff. And then the sort of next thing around production metric-driven requirements. So understanding what's going on in production. And we don't see a lot of companies get to this because they need to have a very good continuous delivery pipeline already. But it starts to shift the way that the business thinks. So instead of thinking about budgets and stuff, they're actually thinking about how do they maximize the value? What can they experiment with now that they have the capability of releasing things very quickly? So what I feel is that continuous delivery it's an extension of the idea of CI. We're extending Agile to beyond development into production. It's the idea that we're building systems and not software, because systems involve the people and the process. And there's a lot of things that we can do to actually get benefits from this. Any questions? So the question around, there's something about getting fast feedback, but doing inside-out development kind of is delaying feedback. How do you balance that? I think a lot of the key to that is really working in those small slices. So when we're talking about small releases and stuff like that, when I talk about inside-out development, I'm thinking in the scale of a day or 2 days. So the check-ins that I have don't have any impact on production. And you kind of combine that with things like feature toggles. So once you put that UI layer in, unless you do something and the business hasn't like signed that off, then it becomes obviously instant to people in production. So you might combine a couple of those different things. Does that answer your question? So the question was, what's the optimal time for user acceptance testing in a sort of CD sort of environment? It's a very difficult question because I think a lot of that comes down to the nature of your product and your application. So when we talk to customers about things like medical devices and things like that, a user acceptance testing phase often becomes a lot harder because the criticality of getting something wrong becomes a lot harder. When we're talking with sort of web services and sort of cloud-based software as a service type things, most of the time, if things break, it's not really a big problem. And so a lot of that is really, I guess it comes down to your testing strategy, which is a trade-off of effort and the value you get from a risk perspective of the business. So for a lot of clients, I guess for each sort of story feature, that might be, I don't know, a couple of days worth of development. In my experience, you tend to have a ratio of maybe an afternoon from a QA doing exploratory testing around that sort of stuff. And then depending on how big and how many features are getting developed, maybe a weekly review by a end business user going through the flow and making sure that things are okay. But there's so many features, or so many factors that go into that. How big your development team is, how complex one change has on everything. Yeah. So the question was, what's a good strategy if you're dealing with large sets of data and you're trying to do a migration or something? And they're used to real time. So we have dealt with sort of CD and migrating, particularly large databases like terabyte type stuff. Doing a SQL statement on a database as it's running live becomes very difficult. So there's different strategies for that. The principles stay the same. So one is you don't really make any breaking schema changes. So you try to design software so that it can operate on 2 schemas. And then the migration side, depending on how long a SQL statement takes, you might have to do like incremental batch updates. A lot of the times it comes down to software design, so allowing code to heal. So a good example is when we have like or NoSQL sort of, or schemaless kind of databases, where it's the code that kind of does the upgrade for that sort of row. So it might pick up one record, and then it does the migration. So you end up with sort of schema evolution in your code, as another example. So it's kind of a function of how much control you have of the environment, and I guess how long it takes to update, make changes to it. Yeah. So the question was, user acceptance testing is a human thing, therefore it's going to make mistakes. How do you deal with that if you're building things on top of that? I think that comes down to really your testing strategy. If it's really important, you'll throw more time at doing the exploratory testing. At the same time, you can't automate, and it's not the return on investment on trying to check for every possible error isn't possible at all. Like, even a simple system, it's just impossible to do all the test combinations possible in order to validate your system, let alone go through it. At the end of the day, it becomes a risk-reward type thing. around how much confidence you would like to have. And the key thing is, we go back to that principle of continuous improvement. When you find an issue, the question is, what are you doing to prevent that issue from happening again? Sometimes it might be about design strategy, about the developers. It might be about creating a unit test around the area of code to prevent any regressions around that area. We have a thing where when I'm working with developers and there's a bug, you normally have a cluster of bugs around the same sort of area because the bug source is often some behavior that's happening. And so when I triage bugs and I'm looking at sort of fixes, I don't just fix that one bug. I'm also working with developers to look at what other possible instances of this bug or what classes of bug have we got around the sort of code base. So it's really trying to spend time on that root cause analysis and then looking at how you bring that feedback earlier into your pipeline. I think the normal reaction is user acceptance sort of test failed or we found something in production. We'll write an end-to-end acceptance test for every one of them. That'll be great, but you'll end up with a very slow running build at some point. So the key to this is really looking at how you get that feedback earlier and faster. Have we tried to measure the return of investment of continuous delivery in some companies? To be honest, no, we haven't actually. It's kind of interesting because I think what's interesting is budgets often come into two flavors. You end up with business budget and IT budget. It's just the way that a lot of companies run their business. And actually trying to measure total return on investment is very difficult. What we do measure is how well the business is doing overall, and in terms of how good can the business actually do stuff. And often CD is about breaking that silo down of sort of IT and business and actually trying to align stuff. And sort of more qualitative type of stuff, it ends up being a much nicer working environment for everyone because developers actually get to see their software in use and you know, helping the business instead of simply just completing some project request or something like that. So there's a lot more engagement from technology. Also at the same time from a business side, that capability often unleashes a whole set of things they've never been able to do before, which is things like experiment and even ask for innovation from technology. So CD often is moving the bottleneck away from software development into the ideas of the business. And I'm yet to hear a business that says we don't want that. So what if the business says they don't want the capability to release on demand? Yeah, so the question is what happens if the business don't want that, and should the development push for that? It's quite interesting because often when we work with clients, when we're delivering a project for different clients, you know, we don't really say we're going to do CD for you, right? So it's just how we work, and we have that capability. But what people start to realize is that they don't really ask for it, but they start to recognize the differences of behavior. So, you know, it's the idea of, once again, you're pushing the bottleneck upwards, but it doesn't mean that you have to force the business to make decisions. It's just that, you know, when the business say, we'd like to do something, it's really simple. You know, whereas their experience often working with other sort of companies is actually they'd like to release something, and there's this whole flurry of activity around sudden deployments, around, you know, checking to see if releases kind of work. So I would say that even if it's not requested by the business, it's part of our responsibility, I think, to be able to do that. Because, you know, software doesn't get created just because we want to write software. Well, it does, but often it's not really adding value to the business. It's that software is there to serve a purpose, and that's part of that supporting the business sort of stuff. So I see it as a way for us to help the business do whatever their goals are. It's, you know, it's nice that it's there. Yeah. Yep. So thank you very much. I'll be around in the coffee break. So.